Well, hello, friends, and welcome back to DevTools hacking once again. We are going to continue working on the IDE, so let me just show you where we left off. Basically, now we have an integrated console here that we can initiate a build with Ctrl B, or you can also go in the menu up here actually and hit build. And then you can run, and it will run in the little window down here. So this is all pretty handy. So the feature I would like to do today is find in files. And the idea that I have for this is that down here where you see this terminal view right now, I'm going to put this in a tabbed container so that I think we'll call this something like the console. And the console will be one tab, and then we will have a like find in files tab or find tab or whatever, search, I don't know what we'll call it, maybe search. And in that thing, we'll be able to type something in and search for it, and then it will look through all of the files in the project and give us a list of all the hits. And if we click on one of them, it will take us to that location. So let's build that. Just get some tea first. Okay, there we go. So first thing we're going to do is just add that tab container thing. So we have a widget for that already in libgui. It's called gtab widget. And the way tab widget works is that I'm just reminding myself that you add widget to it. So it functions like a regular G widget, and then you add widget whatever you want the different subtabs to be. And when you add a widget, you also say, what is the caption of this tab or whatever. I don't know what we call it. I guess there's no name for that particular string, but caption, label, name, whatever. So we're going to do that, and then this, where did we have this terminal wrapper thing? Here. So we're going to, the space that the terminal wrapper thingy occupies in the UI right now, we're going to replace that with the tab widget and then put the terminal wrapper inside of the tab widget. So tab container, we'll call it tabs. Oh, that's a weird, plural is weird though. Tab, we'll call it tab widget. Tab widget construct. We'll put him in the inner splitter so that he takes up this guy's space on G tab widget, sorry. And then we will instead construct this thing with no parent, and then add him to the tab widget like this. Call that console, terminal wrapper. Okay, and let's just see that that turned out the way I imagined it in my head. Oh, no user physical page is available. What the heck? What's going on? Suddenly we are causing the kernel to exhaust all of its physical pages. That's really surprising. That normally does not happen when messing around with user space. Okay, so what if we don't do that? And oh, well, okay, so we'll do that, but we won't add it to the tab. Just figure out what's happening here. Okay, so it only happens if we add it to the tab widget. All right, so add widget will cause us to add child. Why would that be weird? I don't understand why this would be weird. Tab widget just adds it to this thing. And the children of a C object is just a vector of C objects. Okay, well, what happens when we add the widget? Then I guess we get some kind of a layout event. Is there some kind of layout event explosion or whatever? Because I know that maybe it's a resizing thing that happens. So let's see. We add the widget, and then we add child, and this will cause a child added event to be immediately sent to the child. And who cares about that? Well, gTabWidget does. So a child added is given to gTabWidget, who will call setActiveWidget child. And then we will do child set visible false. Oh, no, wait, no, that's the else case. So we should be here, setActiveWidget child. And it should become visible. And then we should set a rect on it. And that will cause a resize event on the terminal wrapper, which will go, okay, why is this happening? Let's add some printfs. And by that I mean some debug output. Let's see here, gTabWidget child event. Just to let us know that we got that. And then we do one for setActiveWidget. Okay, just to give ourselves some idea of what's happening, let's see if this is being called multiple times or something like that. So setActiveWidget is the last thing that we see. Okay. And let's see if we actually return from it. Exiting. Okay. Set relative rect of active widget. Child rect for size. Okay, so we are setting a negative size widget. That's definitely suspicious. I'm guessing that's what's going wrong here somehow. Child rect for size. So is the issue that our size is tiny? Let's say my size is size. So maybe the tab widget has a small size. But the tab widget is inside of the inner splitter, which should be sizing it. But I guess if we synchronously do this, then it hasn't been sized yet. So we die there because the size is 0, 0. Okay, so I think what's happening here is that the tab widget, when we call add widget here, then terminal wrapper is added as a child of the tab widget. And when the tab widget learns that he has a new child, then he immediately tries to resize the child based on the size, the child's own idea, based on the tab widget's idea of its own size. But the tab widget has not been properly laid out yet. I think that's what's happening. Because the splitter that the tab widget is inside is going to lay out when it's a gbox layout. So, okay, so gsplitter just uses a regular box layout, and then it hooks into the mouse events to detect if you're like dragging in between the two the things that are in that layout. So when would the layout happen? That would be in gwidget layout. No, what does it do? Layout. Handle resize event. Right. So when we handle the resize event in the widget, that's when we will do the layout for the first time. So basically, we add a child, but by the time we add the child, we still haven't done a layout. So that means that our size is 0, 0. And in that case, we can't go here and make the widget smaller than 0, 0. Negative size. So that should actually be, we should probably protect against this somehow. So I think child rect for size, the purpose of this function is to, I mean, based on if the tabs are on top or the bottom of the widget, it's supposed to give you the total rect that the child, like the tab contents, can occupy inside of the tab widget. So excluding the tab bar itself, the child rect is like the rect inside the tab widget that's for the contents of the tab. So I think what we should do here is to just tweak these things a little bit. We'll say rect. Break. And then if rect is empty, return. This way we always return a like a normal looking rect if it ended up like smaller than 0 by 0. It's like we're kind of working around it a little bit here, but I think that this will be a decent enough solution just to make our problem go away. Okay, there we go. Now this is looking more sane. So Ctrl V for build. All right, so now we have our little console tab here. Cool. Let's commit that. So what was this change in the GUI here that we just make child rect for size? Oh, we don't want that one. Child rect for size, we want to make sure that the empty rects are just 0, 0, 0 by 0 pixels to prevent trying to set a goofy size on the child. Set relative rect. And I guess in gwidget set relative rect, we could also, I was thinking like if we get a goofy rect here, we could do something, but let's not care about that at the moment. Or maybe we can care a little bit, a tiny bit, because this was a bit hard to find immediately. So let's just assert that the rect width is greater than or equal to 0 and rect height. Otherwise, things can get annoying. So just to make sure that this is not a hugely breaking change that starts asserting everywhere, let's just do a full build and do a smoke test. Because, I mean, if we end up asserting this all the time, then this is something that we should fix. But it's a little bit out of the scope of what I want to do now. I feel like I'm already, you know, heading a little bit sideways here. So I want to get back on track with the IDE. But this will be quick to test out. Just finished building already, brah. Why is this so slow? What's my computer doing? this. Okay. Well, seems like we're all good. And yeah, everything's all good. All right, so add GUI. Okay, so lib GUI. Gtab widget should not pass negative sized rects to GWidget. Should not set children to have negative size. This could happen if a child is added to a gtab widget before the gtab widget had its first layout. Also add an assertion to catch this in GWidget set relative rect, since it was not immediately obvious what was happening. No, that's no smiling matter, it's a serious assertion. Okay. So let's add now, oh, hold on. Let me just commit this change to the Hack Studio as well. Hack Studio. It's annoying that like my cursor in Vim ends up in different places. I guess it's like remembering the cursor position of the last time I edited this commit message. So like it ends up on a different line every time, and I always have to like start by jumping to the top. Anyways, put the console terminal wrapper, console terminal wrapper in a gtab widget. This will make it straightforward to add more things to this. All right, so Hack Studio main. Let's add the find in files thingy. So I guess we can put that. I was thinking we could put it front and center, but yeah, let's just put it front and center for now. Find in files widget, something like that. So build find in files. I'm going to make that in a little helper, and then we'll say tab widget, add widget. Actually, we can just pass it like this. Okay, and then let's make the helper for that. So non-null ref footer gwidget build find in files widget. Okay. Gwidget construct. So let's just make like a really simple thingy here. We'll say text box. Text box construct. I don't have text box. Okay, we'll get text box. And I'll put you in the widget. We're just going to do a very, very simple layout for this, I think. It doesn't have to be fancy at the moment, because this is more about implementing the actual find in files functionality, right? So set layout, make gbox layout, orientation, vertical. So first we'll have a text box, and then we will add in a find button. G button construct widget, and I need G button. Sometimes I wish maybe I should put like I think I should make a header that includes all of the different widgets. But then I think about the compile times when including that header, and I just don't do it. Because compile time is possibly the lamest thing about this project, because it just keeps going up. Like, other stuff goes up and it feels good, but compile time going up, that sucks. Anyway, return widget, right. So what do we do when this button gets pressed? On clickaroo. What do we want to do here? I guess we want to remember the text box. So we'll just sneakily take a pointer to it like this. This is kind of awkward to do this, but actually maybe I could take this. I could capture it by value. So yeah, actually I should be able to do that. So the issue here is that this function is called, and then whatever we have on the stack here is going to go away. So if I were doing this in main, then I know that whatever's on the stack in main is not going to go away. But since I'm in a different function here, the stack will disappear. So I have to be careful about capturing any references to stack variables when I am choosing what to capture for a lambda in a function here. I'll show you what I mean. Like if you look up here, this is in main, right? And main ends with a call to return app exec. This is where we enter the event loop, and we spend the rest of our life here. So everything that's on the stack here will be on the stack for the lifetime of the program, which means that here, for instance, we have a lambda that just captures everything by reference. So it captures window by reference, and window is up here. And it's just a stack variable that contains a reference scanning pointer to the G window that we're using. But because it's on the stack, it's totally fine to capture it by reference. But in the case down here, we don't want to capture by reference, because if I did this, it will go away. If I do this, it will also go away. Because it's the same thing, it's just it would capture everything by reference. Anyways, the trick to making this work is to capture this individual pointer by reference. By value, sorry. Capture it by value, and then it doesn't go away. Okay, so that's enough of me talking about that. It's just, this is something that kept biting me until I just realized, wait a minute, this is the mistake I'm making. And now I'm finally aware of it. I often tell people that like the key to understanding modern C++ is like figuring out exactly how lambdas and captures work, because once those things are really clear to you how they work, that's when you can really start to take advantage of them, because then this friction disappears where you feel like that like it would be in any way tricky to use them, and they just become a tool for you, which is the way you want it to be. Okay, back to business. So button on click, what we want to do is start the whole finding in files operation, I guess. So we have whatever's in this text box, we are going to search for that in all the files. So I guess we'll just put this in a function like this for now, and it doesn't. It's probably not going to be factored this way later on, but at the moment, I think this will be a good enough design. String view text. All right, maybe we can make that static. Okay, so here now we are going to we're going to want to find all the files that are open and then look through them. So that presents us with a problem, because if you recall how we open files, the way that it works is that when you activate one of the entries in the list view, which is, I'll show you. So when you double click on something here, we say that you activate that entry. And when you activate an entry, you get on activation called back here. And what we do is at that point, we just loaded the whole file, read all from that file, and we set that as the text in this text editor widget here. So at any given time, we really only have one of these files in memory. And for simplicity's sake, it would probably be a lot easier if we would just load them all into memory. Although that's probably not what we actually want to do for, because if I make like the whole Serenity project and load it up here, I don't want it to open all the files on startup because that would just take time, and I don't want it to keep all the files in memory because that would just take space. So we can't. I think it's not right to go that easy route. So what we should do instead is, first thing we're going to need is a way to iterate over all of the files, and maybe there should be a representation for those, but a way to iterate over all the file names. And then a way to search in that file, basically. So how do we do that? Maybe, let's see. So we have the project class, and that's the thing that you saw there on the left. That is a visual representation of this object. And really the interesting part is this vector of string m files, which just contains all of the file names in the project. So if you wanted to iterate over the file names, that would be easy. We could just expose a helper to do that, or we could expose the file names. But I feel like it would maybe be even better if we would expose them not as file names, but as some kind of document or file object, text file object, maybe text file, let's call them that. So Hack Studio will have text file. Okay, and we'll add it to the makefile. Text file.o. Okay, and then a text file will be some kind of representation of a file, but it doesn't have to be open. Like, we could have it sort of, we could always have the text file object, but it might not have the actual contents of the text file loaded, but if needed, it could lazily load it when it's requested. I think that would be a pretty decent thing to have. So let's flesh out a file like that. So I'm thinking, should it be reference counted? Probably, because this is going to have some very confusing ownership. Because I'm thinking, like, what if you have a file that was part of the project and you search in the whole project and you got some results, and now that file is part of the results, but at that point you decide, hey, I'm going to remove this file from the project. But it's still in the search results. So if that happens, then it's nice if you can have it reference counted so that it doesn't actually go away from memory until the search results have been dismissed or cleared or whatever. So I think reference counting is the way to go with this thing. And I guess we'll need a non-null ref footer. Okay, and then text file. We'll have a static non-null ref footer to text file. Create with name, maybe. Create is such an overload. I mean, it's kind of overloaded when it comes to anything that's called file. Like, it feels awkward to say create file if it's not actually creating a file in the file system. But maybe construct with name, that could work. Feels a little bit like further away from like the idea of creating a new file in the file system. So construct with name, string name. Okay, and then let's see, new text file name. Explicit text file const string name. Okay. And of course we'll need act string for this. All right. And then let's have an accessor for the name. And I guess we could have all of the lines of the file could be here optionally. So we could say like, or should we just have the whole contents of the file as a string? What's the easiest? The easiest is to just have the contents as a byte array. And we'll definitely have to revisit this because you're probably going to want to end up having a line cache or something like that. But oh, not byte array, byte buffer. Sorry. But this will facilitate the lazy thing that I was talking about. So we can say that if the byte buffer is null, which is the default state of a byte buffer, we'll have a null value. Where's is null? There's an is null here somewhere. There. If the byte buffer is null, that means that it has no value, no contents. Then we can say that we haven't like lazily loaded the thing yet. And then here we'll say we can do something like byte buffer contents. Oh, and let's make it mutable so that we can lazy load it. And ensure contents. So here the difference is that if you call contents, it may return null if we don't actually have contents yet. So this one can be inline. Contents dot is null. Oh wait, why am I saying it this way? We can also just do it this way, but I'm overthinking this. Let's not overthink this. Let's just say byte buffer contents. And this thing will lazily load the contents, and that's all that we need right now. Let's not overthink it. Okay, and then we need text file.h, text file. And I already implemented this here actually, so forget about that. The only thing I need here is const byte buffer text file contents. No, not you. Contents. Okay, so if contents is null, return contents. So now all we have to do is open this file, so we can do what main was doing, right? Hackstudio main, where we construct a C file. See, I've been avoiding C file create here as well, and slurp up all the text like that. So the file name is mname in this case. libcore C file. Okay, and if we fail to open the file, we'll just give you back an empty byte buffer. Oh, we can't do it that way, right? Oh, I guess we can just leave it alone, actually. So we'll just, if the file open succeeds, then contents is file read all. Okay. So this will work for now. It's definitely not the most beautiful or efficient implementation, because we will, if you find in files, we will load all of the files, but it'll get us forward. So let's see. So what did we do? Find in files. What we want to do here is we want to walk over all of the files in the project and get to them. So let's see how we would write that client code here. First, we need access to the project pointer. because that's here in main. So let's just be a little bit lazy here and make it a global. Graph footer project G project. Okay. Why is that not okay? Load from file is, oh shit, sorry, it's an own footer. Right, own footer. Because G project is single owner, not multi-owner. G project. And then what are we going to do with the project now that we have it? For each file. And then we'll have it give us a reference to the file. For each, let's say for each text file, actually. And then with these files, we're going to say, it would be nice if it was already split into lines, actually, because we want to look through them line by line here and get that. But I guess we could say file, find. Let's have an API on file that gives us that searches in the file. So auto matches is matches in file is file dot find text. Okay, and then we'll have a vector of all the matches, which will be a vector of what's this going to be? I guess it will be like the line number and the string. So line number and string. Maybe just the line number is fine, because we can figure out the contents of the line if we have the line number. So let's just do the line number. Let's say vector of int. Oh, but we still need the file name, obviously. Okay. So we'll make a struct for this. File name and line number. String file name. Okay. And file name and line number. Okay. And then matches in file. Matches append file.name and actually we can use append here. File name and the line number is going to be the match, because that's going to be an int, because I'm going to have this thing give us back a vector of ints. Okay, so I think that API looks kind of reasonable. So let's see, now we need project to give us a series of text file objects for these things. So we'll implement this guy, which will use a template with a callback type. And just like that. And it can actually be const, that's fine. And then we for auto file and files. I guess we could turn these into non-ref footer vector instead. We'll just say that everything is a text file, and we can maybe include that here. Yeah. Non-null ref footer vector. Okay. So for each file, we'll call the callback with the file argument. That's easy enough. Okay, and then we have to actually synthesize these things, because here we were just taking the vector of strings and slapping it into the M files, but now M files is it's a vector of text file objects instead, so it's not quite that simple anymore. For auto file name. Okay, then we'll do M files append. Text file, what's it called? Construct with name, file name. Okay. And then up here where we access stuff in M files, since we're now getting a text file object where we are expecting a name, we just have to make sure that we get the name out, because that's the thing that we care about. Okay, there we go with that. And then we added an API to this guy. What was it? File.find, right? So we're going to have to go in text file and make an API for this. So it's a vector of int find const. So this is going to give us a vector of the line numbers where this string view is found. And I realize now that it will just be easier to do this line by line. I mean, it would be easier if we loaded it line by line, but I feel like then we're kind of duplicating a data structure that we end up having in the text document, in the text editor class. I'm not really sure how I would like to do this. Starting to think that maybe it would be sensible to have like a text file or a text document class, and then the gText editor widget has internally one of these text files or text document things, and then you can like take that out of the text editor and manipulate it, but you don't have to be text editor to do that. I think maybe that's the right way forward here, but I'm gonna work on this a little bit and then sort of figure out what the design is as we go. But it would definitely be helpful to be able to take the object or sort of the state inside of the text editor and have that accessible to the outside world. Because right now, gText editor is kind of a black box that has this line, this list of lines inside of it, and it knows things about those lines. And from the outside, we don't know anything. So we end up. That's why I was saying we would end up here having to duplicate the line data structure, which I don't want to. Anyways, that's enough complaining about that. Let's just do something. So text file find. Needle. I like this nomenclature of the needle and the haystack. I always find that very compelling. When it comes to like implementing any kind of search functions, talking about the needle and the haystack is so obvious which is which. So I always call them needle, and now the text file itself is the haystack, so I don't have to write out haystack, but I always use this name because I know what it means. So I guess we just want to iterate over lines on the fly here. So we will iterate through, we'll keep a line counter. Line index is, say, 0. Maybe it should be 1-based. 0-based, 1-based. Let's be 0-based at the moment, and then we can figure that part out later. Line index 0, and then 4. And contents. Oh, actually, we're going to have to make sure that we have the contents loaded here, so we'll just do this. Note, this forces us to load the contents if we hadn't already. Okay, and then I'm just going to iterate through the thing. And then if ch is this, then it's a new line. And then we'll say ++ line index. Okay, and start of line. Wait, how do we do this? Start of line 0. That means that the start of line is going to be, when we get a new line, then the next line starts on the next index. +1. Okay. Continue. So here, when we get a new line, we can make ourselves a string view of the line that we just seen. So that's a string view with start of line, and the second argument is the length. Oh, wait. Start of line is mcontents data plus start of line. And then the length, which is the I minus start of line. Line, do we have contains here? We don't have contains. I don't have contains. Dang it. Do I have some contains thing? String view should have contains. Oh. Wait, does string have contains? It has matches. There's no find string in string other than matches. Matches is for globbing. Or starts with. It's not really what I was looking for. I don't have a string contains. How is this possible? Well, I have stir. Do I have memster? Is memster a thing? Let's turn that. What is it called? I have a, see, a needle in a haystack right here. Mem. That's the name of it. Mem. Do we have mem? We don't have mem. Dang it. All right. Wait. I've done this before. I wrote some frickin' find functionality in text editor. Gtext editor has find. Oh, I see. But it's using these internal gunk of the text editor. So, sad. Okay, I don't want to write this code right now of finding a string within a string, because it feels too much like a programming interview whiteboard problem, and I'm not in the mood. So we are going to hack our way out of this, and then I will come back later when I'm a good boy and do it the good boy way. But right now we're just going to turn this into a string and then run stir on it. Because please tell me we have stir. Yes, we have a stir. Okay. Oof. Start of line is I+1. Why don't we like? Oh, right. Temp is line. So the reason that we do this is actually we can do it this way. String line. The reason that we have to turn it into a string is to make sure that it's null terminated. That's the really hackish part here, because string view is not null terminated. It's just a view onto a character pointer and a length. So there's no guarantee that it's null terminated where you expect it to be. But if we create a string out of it like we do here, then string is always null terminated. So let's say hack alert. Fix me. Please come back here and do it the good boy way. Do this good boy way. Then. Now we can stir. And I forget what is the API of stir again. Stir. Haystack needle, right? Okay. That's good with me. Oh, so yeah, we get it here too. And let's see, auto found is stir of line characters and needle characters. And I'm taking a stupid string view here as well. Okay, so we're gonna not do this the good boy way either. Needle as string, just because I want to have a guarantee that it's null terminated. So we'll come back here and do that the good boy way later. And then if found is not null, then we will add it to our matches list. That will be our current line index, which will increment after this whole thing. So then vector int matches, maybe this should be called matching line numbers. Matching line numbers, okay. So we did various things wrong here, apparently. Got some red up here. And what else don't you like? In main CPP 164, I'm doing this, which you don't like because matches and gonna do it that way. Yes, okay, fine. And then finally, did this capture here go wrong? Oh, I was talking so much about that capture, and what? I'm messing it up because no match for call to, it's just the wrong lambda signature. Because Onclick gets the button that's being clicked as an argument. See? So we have to put auto here, otherwise it doesn't recognize the signature of the lambda. Okay, but we still don't have enough for this to actually do anything, but we could dump out this list of matches. So for auto, matches, match in matches, I guess. Match. Match.filename and colon and a match.line number. Let's just see if something comes out. I'm kind of curious. Will this even run? Okay, we are alive. Look at this beautiful AI here. UI, sorry, not AI. And it seems like when we searched for an empty string, then it found lots of matches. What about if we search for like main plop, and then we don't have so many matches, we have these. So main CPP line 2, that's here, with lines of 0 based, so that's actually line 3, right? And makefile line 1, should look at like line 2 here, has main on it. Okay, so this definitely seems to work. But let's fix up the UI here a little bit because it looks a little too crap for my taste. We're just gonna set a size policy on the text box and the button. Size policy, we'll say that what are we gonna say? We're gonna say that it's horizontally it's fill and vertically it's fixed, and text box set preferred size. Horizontally don't care, but vertically 20 pixels. And then we'll do it actually exactly the same for the button. So we'll just give it all the horizontal space, but only 20 pixels of vertical space. And then we can also set a label or a text on that button, which I think we can just pass it here. So find in files. Okay, it's a little bit better. Main. Boom. Okay, we have it right here. So what do we do with this now? I was thinking we could like show the results here in just a list view. So we'll put a glist view down here with the results in it. Result view, it's glist view construct. And that can occupy the rest of the space. And we'll say result view, set model, or no, actually. What are we going to do with that? We're going to need a model to contain these things. So let's make one. Let's grab some model that we already have. How about the project one? It's pretty simple. So this is already starting to feel like it should move to its own file, but we'll keep working on it in main for a while, and then we'll figure out what kind of components come out of this. So call this search results model, something like that. And search results are going to be constructed with one of these, let's say, vector of these. And it will just allow you to copy it in. And let's put this outside so that we can access it. Okay, and then matches. Okay, and this implementation here, we don't care about font, so this actually becomes much simpler. We're just going to have a vector in here of file name and line number. And when you ask for the display role, we'll just give you back the match at I. Or actually, hold on. Let me format a beautiful string out of this. So it will be the file name colon the line number. Oops. Row, index row, dot file name dot characters, okay, and then matches at, oh, let's put this into a temporary. Index row like that. That's a little nicer. And then we can just say match file name characters, match line number. See? That's pretty tidy. And then column count is 1. I think that's fine. And the row count is just how many matches we have. Size. Okay. And then when we do the find in files operation, we will have it produce a model. So we'll have this thing return a ref footer to a G model, or actually it can return this model. And we'll just say return new search results model with the matches. And in fact, we can move those matches here. We don't have to make a copy. We can just move them. Save ourselves a little CPU work. Okay. And then down here, we'll say model results model, and all we have to do is save that in the results view. Results model. Of course, then we also have to capture the results view. And it was called result view, sorry. Why don't you love me? It is a const glist view because I'm capturing by value, and that makes it const. Ugh. How do I get a non-const value? Maybe I don't. What if I do it that way? Capture the pointer. So this is like it's kind of a hackish way to do that. Maybe there's a way to capture a mutable, because I don't want a const copy, I want a mutable copy. But this this gives me a raw pointer instead, because now I'm just rebinding this name to the result of this expression, which is still okay. It's okay to use a raw pointer here because I know that the result view is it's always owned by its parent widget, which I'm never going to tear this down, so it's fine to take a raw pointer to it because it will never go away. Main, find a fuzz, plop, and look at that shit. How cool is that? That is very cool. Maybe we should tweak those line numbers to be human readable here. But it's sort of making me feel like maybe the line numbers should come out human readable from the find function. So let's go in text file find and do that. We'll append +1. Okay. And then I'm kind of thinking that when you double click on one of these guys, actually maybe this should have two columns, like the file name and the line number, and then the contents of that line. But okay, that's too much. Let's focus on what we want to do. So the remaining thing I want to do is, if I double click on one of these, I want it to actually open that location here in the editor. That was the last thing I wanted to achieve. So let's make that happen. Result view on activation. And then we'll get the index that's activated or double clicked. And then what we're going to do is we're going to grab the file and line number information there, which we have. I think, yeah, that will be okay. So let's see how we do that. We could actually be a little bit cheeky here, and no, let's not be cheeky. Let's do it the proper way. So let's say location is the location that we want to open, or match string, is result view model data for the index, and we want the display data, and I need the result view here. Result view is a pointer, right? The G model is a pointer, so that's good. Now we have the match string. Now we just have to open that file and go to that line number. So we'll be a little bit, this is going to be a little bit silly, but we'll split it out. Like, obviously there's more efficient ways of doing this, but since we have it as a string that's file name colon line number, we're just going to make use of that. So say parts is match string split by colon, and assert parts size. We should have 2 parts. Okay, and then Let's take out the line number is parts1 dot to uint. Assert, okay, just assert that the conversion worked out. And then, how do we go to we have some go to line thing. How did we implement that? Okay, so we want to make sure that we open the right file. So first we have to open the file, and then we have to go to the line number. So these things are actions that we already have, but we're going to have to like factor them out into functions so that we can call them. So here's when you double click on a file to open it. Let's just we'll put this in a separate function like this. Open file. Okay, static void open file. And then we need to access these things. So we're sort of discovering here what's going to become globals, or not globals, but probably member variables of something. But for simplicity now, we're just going to make things global. I mean global inside of this function, inside of this file. And then this sort of process will inform the class design that we eventually make for this whole thing. So let's see, where did the window equal? Okay, so let's rename you to gwindow, and then we'll say ref footer gwindow. Okay, and then we had gTextEditor and gProject list view. Text editor. So we'll rename him to gTextEditor, and where's the project list view? Here, okay. So we'll rename that one to that. Okay, and then we just put these up here. glist view. And gTextEditor is gTextEditor. All right. So now open file does this, and here was a missing use of window. Gvariant has no member name split because this is not a string until we do toString on it. Okay. Now so now we have open file, which means that we can open file parts 0. So we're opening, remember here we were splitting the file name : line number into 2 parts. So we open the first part as the file, and then we want to go to line number. And where's that action? Here's the go to line action. So we just take the part here, first we just ask for a line number to go to. But once we have that, then actually this is the whole go to line thing. So we could just, we don't need to have that in a separate function. We can just do it that way because that's exactly all that we needed to do in there. Just set the cursor of the text editor. That's the whole thing. Okay, so main, boom. Oh, enter doesn't work. There we go. Double click, and I don't know if you can tell, but we are on line number 2 there. So double click, we are on line number 3. Oh man, that's so cool. That's very, very interesting looking. But in text editor, the text editor app, it doesn't start now. Oh geez, what did I do? Oh, that whole thing with the assertion. I guess that assertion maybe was a little bit aggressive, but box layout, run. You know, instead of asserting, we could also just say if a rect is a rect is empty. If so, it's an empty rect. Otherwise, use a rect. Okay, we just neutralize the problem. Because I don't want to deal with that anyway. Piece of ginger. Whew. All right, so text editor, what do I want to say? I guess it looks okay. I mean, I don't know what I was thinking. I forgot. I just wanted to see something. So I guess little, if we search for little, then we find it here and here, right? That's there and that's here. Obviously, this feature could be a lot more mature. Like it could, when you double click, it could select the matching string or something like that, and it could show the matching string here. But I think that we have managed to build a cool little feature regardless. Obviously the UI is not perfect, but it is functional, and we're learning about what kind of things we need as we go. We see that building and running still works. Bloop. Isn't that nifty? Very nice. Okay. So let's add that lib GUI thingy. Widget. On second thought, don't assert on negative sizes in rects. Just neutralize incoming negative size rects in set relative rect. Okay, and text file, I kind of don't love that name, so I think I'm going to rename it to text document, I think, or yeah, I'm going to rename it to that. So text file. Wow. Wait, where did we have matches for that? Only in these things. Okay, so that's easy. Then we can just search and replace. Now that I'm using Qt Creator, like the IDE here, then I'm suddenly so aware of all the little features that I'm using. So like find in all files and then replace in what you found. And these are all very nice features that we should implement. But one at a time. One at a time. So text document, I like that name better. Hack Studio, and the make file is going to say text document. And then, as I was saying before, like my ambition probably is going to be to have that be something that Gtext Editor has internally. But right now we'll model it this way. But like maybe long term, I would like to move this into Gtext Editor and have it as a way to expose more of the internal data structure of the file in the editor. Anyways, let's rename those files as well. So text file CPP becomes text document CPP. Oh geez, I did not type MV. Text file star, okay. Cool. Let's see that we can still build. Okay. Boop, boop. Cool. And we search for printf. only find it here, and that jumps to there. You can barely see that it jumps, but you can see that the line number and the ruler here gets bold. That's how we know. I'm thinking maybe we should focus the editor when we do this. Maybe that would be a nice cue. Say text editor set focus true. Maybe that would make it a little bit nicer. Let's see. Switch main. Keep pressing enter there, expecting something to happen. Okay, so now when I clicked it, it got focused. You can see it blinking. Boop. Boop. Yeah, it's pretty cool. Okay, so let's commit this. Git add. Wait, what did I change in main? Let me just take a look at that for a moment. Project name. Nothing actually changed. Yeah, so I can do this project change, text document change separately from the main changes. Although, I mean, it already contains the find functionality as well, so it's kind of silly. Okay, let's just do everything in one big commit. So Hack Studio, add. Start adding a find in files function. Show project now contain set of text document objects. Each text document represents a member file in the project. Text documents may not have their file contents loaded at all times, but they will be loaded on demand when calling text document contents. To implement, let's see, find in files works by iterating over the text documents in the documents in the project and calling find on each one. The return value from find is a vector of line numbers where the needle was found. The UI here is obviously this is obviously going to need a bunch more work, but it is a cool start. So it's pretty nice. I'm gonna want to polish it up a little bit though before I end the video. So I want to be able to press enter here, for instance. That's this obvious thing that we should have. So button Onclick. How about we do this the funny way, and we just say text box on return pressed, capture button, and then when we press return, we say button click. Can we do that? Oh, it's const. I'll have to do that thing again. That's fine. It's a little bit weird, but it's okay. And then, what else was I thinking? I wanted to have, in QCreators, Ctrl-Shift-F to open up the, like, find in all files thingy. Or wait, it's just, or is it Ctrl-Alt-F? Ctrl-Shift-F. Yeah, Control Shift F. Okay, and I want to have the same thing here. So let's make some kind of action that focuses that thing. So how do we do that? We have to have, we'll add it to the menu, I guess. So we'll make a, that's the build menu. We could have an edit menu, maybe. Edit, or no, find in files. Control Shift F. Focus find in files, or make another global here. Find in files text box focus, and then actually we're also going to want to set the find in files widget to be the active widget in that tab widget that it's in. So where's the tab widget? Tab widget. Set active widget g find in files widget. That one maybe we can actually just cache up here. Yeah, we can just do that and we'll have him. But the text box we have to stash away. And we'll call this the edit menu. Okay. Text box will be named to g find in files text box. There's no such thing called focus. Yeah, right. Set focus true. And oh, and we don't need to capture it anymore, obviously, because it's global now. Okay. If I go here, but then I press Ctrl Shift F, then I'm here. And actually, it would be nice if I could start typing right away. So if I'm here and I press Ctrl Shift F, I would like it to select all in this widget, so let's do that. Where's the mod shift thing? Here. Let's do g find in files text box, select all. This is so hackish right now. But we're getting sort of the behavior that we want, and I think we're learning that find in files thing should be a separate class, probably. It shouldn't be in main like this. It got really messy. So yeah, I just wanted to check that behavior. Go to console, Ctrl Shift F, main is selected, I can start typing. Okay, awesome. So now we were just making it keyboard accessible. Yeah. Hack Studio, make the find in files widget a bit more keyboard accessible. Have Control Shift F, open the find files widget, and focus the text box so you can start entering text right away. Also make a search media when you do a search when you press the return key. Cool. Okay, this is too messy here, so let's put it in a separate class. Just as the final thing that we do today. Create a find in files widget. Okay, and then find in files widget. Find in files widget. It's just a public G widget. And it will have a virtual find in files widget. And in files. Okay. And let's see, we're going to put some members in him, I guess. So we wanted to have a way to focus it. We'll say open, maybe. Or like maybe open. We can call it open. I'm thinking, just what do we call this thing where I press Ctrl Shift F and it opens that thing and selects the text and focuses the text box so that we can start entering. Open is the best name I can come up with for that. Or I don't know. Focus text. Focus text box. That works. Focus text box. Focus text box and select all. Very, very clear what that means. Okay, and then text box. Okay, and I'm gonna need that up here as well. Build find in files widget. Where are you? Here. This thing is going to be here instead. So widget is now us. And this guy is just called mTextBox. And we're going to need all those things. So gbox layout and gTextBox and gbutton and glistView. Okay, so it's still going to look the same. It's just going to be like in its own file, which will make this so much easier to work with. mTextBox. And then that means that we can just capture this. We don't have to do this gunky stuff that we were doing. So result view we can rename to mResultView. Button we can rename to mButton. And result view, okay. We just need to declare those classes. Okay. M result view. Oh, we need to capture this, right? So now the last remaining thing here is that we don't have this function anymore. Find in files. So let's see, let's put it in the find in files widget for now. And then we need access to this, but we know that it's an extern. I'll put it to project like that. These globals are going to go away, obviously, over time. As you can see, we're discovering the class hierarchy and the different objects that we're going to need. I don't know why I keep saying that. It's like I feel bad about having globals, I guess. That's good. And then when we do the build, this thing here, find in files, this action, what it needs to do now is just to do find in files widget. What was it called? It had a name. Focus text box and select all. Right. Text box. Set focus. True. Okay. Text box and select all. Where's the find in files widget? Here. So this is going to be find in files widget construct inside of the nothing, and then we'll add it to the tab widget. Yeah, definitely something I was not remembering there. Open file. We need open file. So open file is only in main right now. But what if it were not static? Then we could get to it from this other file. So okay. Now I just need to get rid of that function and we should be good. Oh, crashy crash. Where did we crash? Inputter in the G button click. Where's click? Find in files with the text box text. Wait, who's, well, with T project. Okay, there we go. Wait, what? G button, click. That's this lambda. What am I, why am I? Oh, we're here. Oh, I'm so stupid. Look at this. I'm trying to declare an extern. Okay. But I instead ended up declaring a local. That's why it was not working. Okay, so main. And it is working. Right, so now we just moved it to its own file, and it can pollute the main file way, way less. I think that turned out pretty okay, because main here is already confusing enough. Okay, so let's commit that and then be happy with it. Hack Studio, move find in files widget to its own file class. Instead of clogging out main CP. Put it find in files widget class in a separate file. Nah, not this time either. So I think this is going to be it for today's video. So we have successfully implemented the find in files functionality, where we can search in all the files in the project. And obviously the UI is far from final, but just wanted to build a little feature so that we can keep moving forward here. And this is something I use a lot, so I wanted to add it. Anyways, I hope you saw something interesting here, and I thank you for hanging out, and I'll see you next time.